Here's a short video on combined gas law and ideal gas law. So combined gas law just assumes that the amount of gas stays constant and everything else is changing. So we're not going to deal with moles, but we are going to have to deal with pressure, volume, temperature. Okay, and here's our equation. Looks very similar to the other gas laws, only everything's there. So here's just a sample problem. You have 15 liters of argon gas at 25 degrees Celsius and 200 Kelvin kilopascals. What is the temperature if the volume changes to 40 liters and the pressure drops to 115 kilopascals? So my equation is P1 times V1 over T1 equals P2 times V2 over T2. So this whole first sentence is going to be one side of the equation. I need to change my 25 degrees Celsius to Kelvin. 25 plus 273 is 298, so that is 298 Kelvin, so I'm going to use that instead. So I'm going to plug in, I'm going to go 200 kilopascals times my 15 liters over 298 Kelvin. That equals the other side of the equation, so everything else is going to be on this other side. What is the temperature if the volume changes to 40 liters and 115 kilopascals? So I'm solving for T2. So how am I going to solve this? Same thing, I'm going to cross multiply and divide. So I'm going to cross multiply away from my unknown. So I'm going to multiply all three of those numbers. So I'm going to go 298 times 115 times 40. And then I'm going to divide by both of these. The ones that are with my unknown, I'm going to divide by. So I'm going to divide by 200. Then I'm going to divide by 15, and I get T2 is equal to 456.9 Kelvin. Okay, that's how you solve combined gas law. And you use this equation when everything changes. So temperature, volume, pressure, everything's there, including everything, and everything changes. You will not use moles, though, with this one. So the next law is if there is moles. Okay? So it's called the ideal gas law, and it means that we're going to change our volume, our pressure, our temperature, and we're going to deal with moles. So pressure can either be in kilopascals or ATMs, but you have to make sure you use the appropriate gas constant. Volume has to be in liters. N is for moles. That should be lowercase. Sorry. And R is the gas constant, and T is temperature. Again, has to be in Kelvin. So here's the thing. If you use kilopascals, you're going to use 8.31. If you use ATMs, your R is going to be 0.0821. So everything is a factor. So one problem. Here we go. You have 35 liters of hydrogen gas at 30 degrees Celsius and 1.25 ATMs. How many moles of hydrogen do you have? So here's our equation. PV equals nRT. It's called the Pivnert equation. So my pressure is going to go here, 1.25 ATMs. Then I'm going to put in my volume, 35 liters. How many moles? I don't know N. What R am I going to use? Okay, if I'm in ATMs, I'm going to use 0.0821. So that's the R because this is an ATM, so I'm going to use the appropriate R value, 0.0821, and that's liters of ATMs over moles Kelvin. Okay, and then my temperature has to be in Kelvin. So 30 plus 273 gets me 303 Kelvin. So now I'm going to solve for N. Okay, how do I do that? Well, I got to get everything by itself. So I'm going to multiply these two, and then I'm going to have to divide both sides to get N by itself. So it's going to look like this. I got to divide both sides by 0.0821 times 303. I'm dropping units just to get this done faster. And then 0.0821 liters ATM. My pen's running out. Moles Kelvin times 303 Kelvin. Okay, so I'll write this down here. So I'm going to go 1.25, grab my calculator, 1.25 times 35 divided by 0.0821 and divide by 303, and I get N is equal to 1.76. What is N? Moles of hydrogen gas, of H2. That's how I write hydrogen gas. So again, we used 0.0821 because our pressure was in ATMs. If our pressure was in kilopascals, I would use the 8.31 here. Thanks.